Welcome to the Healthy Places North Carolina Data Training Series. In this initial video, we will discuss some basic data concepts. You will learn about some basic data terms, discuss data limitations, and review steps for identifying sources of secondary data. In order to collect and interpret data, it's important to discuss common terminology used to describe data. We can differentiate data into two forms, quantitative or qualitative. Quantitative data can be measured as a number. For example, we can count the number of people with diabetes or the number of people who smoke cigarettes. Qualitative data is information that cannot be summarized numerically. This type of data is contextual in nature. Qualitative data may include information on how people perceive diabetes treatment options or motivations to quit smoking. Data are usually collected on the level of the individual person. Multiple individual data points can be aggregated together to describe health within a population. In public health, we are specifically interested in learning about and reporting on population health at the aggregate level. You can summarize data on populations numerically by conducting a descriptive data analysis. Here, we mention a few basic measures used in public health data analysis. A count measures the number of times an event occurs. A ratio is a relative value comparing the number of people with an outcome to the number of people that did not have that outcome. A proportion is the percentage of people in a whole population that developed an outcome. And finally, a rate is the number of people developing an event within a defined frame of time. In public health, you'll often hear the term incidence and prevalence. Both incidence and prevalence are proportions of the population with a given outcome, where incidence describes the number of new or incident occurrences of an outcome, and a prevalence describes the overall number of people with a particular outcome. With some outcomes, it's important to distinguish between new versus existing occurrences, such as the number of incident HIV or AIDS infections versus the prevalence of HIV/AIDS infections, which reflects the broader context of individuals living with HIV/AIDS. Another common term in public health is risk, which is often expressed as a proportion of a population or group that experiences an outcome among those who are able to experience the outcome. This is a bit beyond our scope today, but is another way to express proportions within a specific population over specific time. For these terms, incidence, prevalence, and risk, you can make relative comparisons between two populations by comparing ratios of the incidence, prevalence, or risk in one group relative to another. These relative comparisons are called incident rate ratios, prevalence ratios, or risk ratios, and they are important concepts when assessing differences or associations between two groups. Ideally, we want the data we use or collect to accurately represent the actual condition within the population. But perfect data does not exist. In this slide, we differentiate between two important concepts impacting our assessment of data quality: validity and reliability. Data is valid if it accurately measures a condition. Let's say we want to measure someone's blood pressure. The blood pressure measurement is valid if it accurately reflects the blood pressure of the person. So you can think of validity like the accuracy of hitting the bullseye of a target. In contrast, data is reliable if we get a similar result each time we measure a condition. If we measure blood pressure on the same person multiple times under similar conditions and we get similar results, then the blood pressure measurement is reliable. You can think of this concept like constantly hitting the same spot on the target, even if it's not the bullseye. It means you're shooting the same way each time, thus the measurement is repeatable. In this case, the data are reliable, but not valid. Other times, it is both reliable and valid. And still other times, it's a mixture of valid and reliable. A common measure of reliability is the confidence interval or the margin of error. The margin of error defines a range in which the true value likely lies. In this case, the margin of error for the percent uninsured in Robeson County is plus or minus 0.7%. Based on statistical properties, if we were to repeatedly pick different samples of people in Robeson County and ask them to complete the survey, The true percent of uninsured people in Robinson would be in the 90% confidence interval of 15.3% to 16.7%, 90% of the time. Recall that data validity characterizes the accuracy of the data. We use the term bias to describe systemic errors in designing our study, selecting participants, or collecting data that impact the accuracy of the data. Two specific forms of bias are selection bias and information bias. When selection bias is at play, our results differ from the true value of the population because of differences between the people selected into your study and the people in your overall population of interest. For example, if you conduct a phone survey using numbers from a landline directory, you may talk to more older people or people who don't have cell phones. Information bias is another systemic error resulting from data that is inaccurately measured or misclassified. For example, if a survey is mistranslated into Spanish, then Spanish-speaking participants may answer inaccurately. Now that we have identified some different types of data, some common ways of summarizing data, and common data limitations, we'll shift gears to considering how to collect or find data. Primary data are new data collected by you specifically for the project at hand. Such data could be collected in person, over the phone, on the internet, or through a mailed assessment. We'll focus on tips for collecting primary data in subsequent videos. The remainder of the slides in this video will focus on secondary data. Secondary data are existing data collected by other groups that we are using for our own purposes. There are many sources of secondary data available at the federal, state, and local level. Secondary data sources are not all equal in terms of quality and utility. It's important to ask questions when determining whether it's appropriate to use a secondary data source. In selecting a secondary data source, you should investigate what data is available from the source. This is an important consideration for determining if the data source aligns with your project questions. Second, we need to find information about the who, when, how, and where of the data source. Are the data from a reputable source? Was it collected recently or from the time period of interest to your study? Was it collected using accurate and reliable methods? Does the data source capture information about the population of interest to you? Finally, consider the important question of why this data is important to your project. What will this data do to inform your question? Here are 3 different data measures that are available from specific secondary data sources. When we think about the source of the data, we want to consider what organization collected the data and how it was collected, in order to determine if it was appropriate to use to address our project questions. Poverty data is collected nationally on the American Community Survey collected by the U.S. Census Bureau. The survey is mailed to a sample of U.S. addresses. Prenatal care information is collected by the state. The North Carolina State Vital Statistics collects birth certificate information that includes information on prenatal care. Local organizations may also collect information that could be useful for understanding your project questions. Naloxone is a medication used to reverse the physiological impacts of opioids. The North Carolina Harm Reduction Coalition collects information on naloxone distribution. Once you have narrowed in on a data source that may have information on a measure of interest to your project, reflect on the method of collection. Some health data is collected in outcome-specific disease registries or reporting systems. We can also obtain health data from sources that collect data administratively for the purpose of running a program. Finally, secondary data can also be obtained from surveys, such as those administered by the U.S. Census. Another factor to consider is the time at which the data was collected. Depending on your study question, older data may or may not be appropriate to use. Finally, data may also be aggregated or added together at different geographies. For example, data collected at a county level by a local health department is sent to the state to be aggregated together to be the state total. Other times, data is available at a finer geographic scale, such as block groups or census tracts. Finally, it is also important to note that in some cases, such as a rare health outcome with a small number, data will be suppressed or only reported at the state or national level. In summary, you will likely need to weigh the advantages and limitations of different sources for data, acknowledging that the choice of data will depend on the context of the project. It's important to select data that is both reliable and relevant to the time, place, and populations you seek to address. We will cover some considerations for collecting our own data in subsequent videos.